This is the Secret Colours experiment. Now in Secret Colours, we're going to be investigating the colours they use to make the colours they put on sweets. Now, you can try different sweets. You can see the ones I'm using here. The thing you want are sweets which are coloured and that if you put water on them, the colours come off. That's a good clue that this experiment will work. Now these sweets I'm using work very well for this experiment. As you can see, I've separated out the colours. Now I recommend you use brown, green, definitely, and one other colour, and as you can see I'm using blue. The reason I suggest you use brown and green is because you can quite often easily see the colours they've used to make each one. Some of the other colours it won't be so clear, but I do think actually that's still a good thing to do. This is what I will need you to now do. So you put a selection of sweets, you do need a few of each because we need to wash the colour from each sweet, but one on its own won't be enough. So as you can see, I've got about 8 or 9 sweets in each cup. In this little bottle here, I've got some warm water. It doesn't have to be hot, just warm, because when it's warm, it dissolves the ink and washes it off a bit more easily. And let me show you what I'm going to do. I'm going to pour the water on so it covers the sweets. You don't need lots. In each case, just pour some water on so it covers the sweets. Now, nothing seems to be happening right now, you're wondering, but what we need to do is agitate a little bit. Now, agitate scientifically means we stir. And as you can see, as I stir the sweets with the water, the colour on the sweets is coming off into the water beautifully. Washes off really well. Now you know this anyway, because I'm sure when you eat sweets yourself sometimes, which you mustn't eat too many of course, but when you do, you probably notice if your hands are a bit hot and a bit sweaty, the colour on the sweets often comes off onto your fingers. And by the way, those sweets that happens with are probably good to use for this experiment. As you can see, the colours are coming off beautifully. Look at that blue, isn't that lovely? Beautiful colour. Come back. And now the green is interesting because can you see the sweets as I slosh it around in there? They almost look like white now. So that shows you the colour of the sweet underneath the colour they put over the top. Same for the brown ones, look. So you can see they all start off the same colour. The colour you see in the pack is just because of the coating on the outside. And even with the blue ones, that's a lovely colour, isn't it? Look at that blue that you can see in there. So all the sweets have actually gone the same colour now. So that's the ink we want to use. Now we need some blotting paper. Blotting paper is stuff that was originally used when people used to write with ink pens, like dip pens. And the ink took a long time to dry with that, it still does if you still use them. And blotting paper is like an absorbent tissue, and you lay it on top of it. When you've written your writing on a piece of paper, you get a piece of blotting paper, rest it on the writing, rub it with your hand gently and peel it off, and it helps dry the ink. Now you can still buy it because people still write with fountain pens. And you can buy this quite easily from stationers and art shops, no problem at all. And in fact, you can see on the table, I've got a big sheet of it here, and I've cut some strips, and here's some of the strips I'm going to be using. Really easy. All you now do is you take a piece of blotting paper and you push it into the coloured liquid, right down into it, and just bend what's left over the top. Now you can see I'm using a very long piece. As long as it's long enough to come up over the top of the cup, that's fine. You'll also notice actually that I'm using clear plastic cups, and I'm sure you've realised already that's so that I can show you what's happening inside. But if you try this one yourselves, you don't need clear plastic cups because you can look over the top. I'm going to leave that one there. And lastly, the brown one. I'll choose one of these pieces and rest it in there and bend it over the top. And just leave them like that for, say, about 5 minutes and see what happens. So, after only a few minutes, in fact, up to now, we're up to 7 minutes, but even long before 7 minutes, the colours were beginning to separate out beautifully. Draw your attention particularly, I think, to the brown one. Of course it applies to all of them, but you look at the brown one, it's beautiful. So you can see the colours have separated out so well. And you can see, I think if you look carefully enough, you should be able to see yellow, cyan, magenta. And of course you will see some other colours with the other colour pigments you use. Okay, so how do the colours separate out? Why do they do that? Well, this works in a very similar way, in fact the same way, as another experiment I can show you, which is called black magic. That's another one you might want to look at. But it also works because of chromatography, a rather interesting science. Now think of the word chromatography. That word tells you something already about it. Chroma means colour, graphy means to write or draw. So it's to do with colour coming from drawing. Now, I'm going to think about the brown one as I talk about this. In that brown, you can see it's separated out to 3 or 4 new colours that you can see quite clearly by now. Now, they use those colours to mix that brown in the first place, and we're just reversing it, we're separating them out again so you can see. Now, it turns out, if we could see those colour pigments under a microscope, the particles, the little molecules they're made of, look different, have different sizes. Now, the colours separate out into different places if you look really carefully. Some will travel further than others. And how far and how fast those colours will travel depends on how big those molecules are of each colour. And because we've got 3 different colours there at least, we're going to have 3 different ways the colours are going to travel. So if you look really carefully, you'll see they've travelled into different places, spread out differently, because the size of the molecules of those particular colours. So the yellow molecules will travel differently to the cyan, for example. It's also got to do with how the water molecules, the colour molecules and the paper itself react together. So that's also a factor. Now, some things you could change. How about trying different colours to what we've used here? Of course, we've used brown sweets, green sweets and that lovely blue, or probably more near cyan now, isn't it? How about trying some different colours entirely? Interestingly, if you can find them, try yellow sweets. See what they do. And if you can find them, pink, see what they do. That'd be interesting. But try other things too. What about if we try different types of paper instead of blotting paper? Now, on the table in front of me, you can see some other things here. These are just strips of napkin. You can try that. The water will travel differently through that. What about these filter paper discs? You can get different size discs, but this is absorbent paper. Why don't you try making some strips out of that, for example? What about using coffee filter paper? Now, this particular paper isn't the best because it's slightly discoloured. It's a slightly pale browny colour, but it does still work and you will see the colours in it. But I recommend trying to find maybe a brighter one as well. But using different colour paper is a variable, so that's not a bad thing in itself. Another thing you could try, instead of putting the coloured liquid that we now have in cups, as you can see here, how about you take the liquid and you pour it into a saucer and then take a piece of your blotting paper and rest it on the plate like that, or the saucer like that, so that the end dips into the coloured liquid you've got here, and see what happens now. Notice, of course, that the paper now is laying down, it's horizontal nearly, compared to when we have it in the cup, when it's pointing upwards, it's vertical. Now that must have some effect. Interesting question is, what effect, and will you be able to see it? So that's yet another thing you can try, and I'm sure you can think of some other things too.